try a trickier rotational solid problem. All right, so I've created an area contained by the graphs y equals square root of x minus 2 and y equals the quantity x minus 2 squared. And I'm going to rotate that area about the vertical line, x equals 1. And I want to find the volume of the solid that's formed when I do that. Whenever you are starting one of these problems, you always want to first draw a picture. Draw a picture so you can visualize it. And listen, if I can draw these, you can draw these. They take practice, but pause the video and try to sketch this for yourself. If you notice, I sketched kind of the solid, and I also sketched a cross section. That's also going to be very helpful to us as we work on this problem. So there I've drawn the solid, and I've also drawn the cross section. And the cross section is going to be a washer, right? In other words, with a hole in the middle. But before we get too carried away, the way I've drawn this, I think you might notice something. I had to draw it around the axis of rotation. Of course, since I said to rotate this area about the line x equals 1. And so hold on now, all my slices, for them to be circles, have to be horizontal, which means to find that radius, I'm going to need these functions to be expressed in terms of y instead of in terms of x. And the thickness of the washer, the thickness of this washer is going to be the change in y, or dy. So before I do anything, I'm going to rewrite each of these functions to So what I did is I rewrote the blue function here. I took the square root of both sides and then added 2. So I rewrote the blue function in terms of y. And I rewrote the red function in terms of y. I squared both sides and added 2. That wasn't too bad. Okay, the other thing I'm going to have to do is to figure out what these points are. Let's see, this is clearly 2, 0, and I think doing a little bit of plugging and chugging, you'll see that they intersect at 3, 1. Okay. I think we have our ingredients. I think we're ready to go. So now I have my cross section as a washer. Let's just remember how we deal with washers. Remember, a washer is a disc with a hole in the middle. So to find the volume of the solid, kind of the big picture idea is you find the area of the big circle and you subtract away the area of the little circle. That's going to give me that shaded region. And then you multiply it by the thickness, either dx or dy, right? Depending on if we're in terms of y or in terms of x. So let's do that here, shall we? Okay, I'm starting off by factoring out the pi, because my big circle will be pi r squared, my little circle area will be pi r squared, so I've just factored out the pi. I am going to find the area of this big circle, which means I have to find the radius of that big circle. Well, the distance from here to here, the easiest way to do that is to think, oh, it's the right-hand curve minus the left-hand curve. I have to, of course, express that curve in terms of y. So it's going to be square root of y plus 2. There's the right-hand curve minus the left-hand curve, right, which is 1. That's my radius So there's pi r squared. That's the area of this big green circle. If you need to stop and think about that, do, because that's a little tricky. Now I'm going to subtract the area of the little circle. I'm going to get rid of the whole. Well, what's the area of that little circle? Well, it's also pi r squared, and that radius is the distance from the red curve to x equals 1. So that's going to be y squared plus 2 minus 1. And I kind of put in extra parentheses. You don't need those parentheses there if those confuse you. And of course now that washer has a thickness, dy. And we are integrating, since we're with respect to y, we have to find the smallest y, which was 0, and the biggest y, which was 1. That's a little tricky. Let's just go back and refresh our memory. We decided that those two curves intersected at 3, 1. Why didn't I use 3 there? I would have used 3 if I had rotated around the x-axis or around an, a axis that was horizontal to the x-axis. But I'm stacking up all of these disks from 0 to 1. So that's kind of tricky. Okay, you could just put this into a calculator as is. If you were doing this by hand, that might be a little bit of a hassle, but if you were doing it by hand, you would certainly simplify this a little bit first. This is square root of y plus 1, quantity squared, minus y squared plus 1 squared, all dy. And then you could do this by hand. Again, that would be a little bit of a hassle, or you can put it in your calculator. Remember, the calculator doesn't really care if you are with respect to x or y. If my calculations are correct, the volume is approximately 3.037 cubic units. So that was a sneaky problem. We had to rewrite the functions in terms of y. We had to find the interval over which we had to integrate. We had to make sure we were using the y interval instead of the x values here. Finding the radius of the big circle and the radius of the little circle can get a little mind-bendy. There are lots of moving parts here, but I hope that the overall concept makes sense to you.